Hello. Hi.
Hi.
Hey, everybody. Hi, how are you?
Hi. How's everybody?
Good, good. All right.
Yeah. Hi. Am I audible now?
Yes. All right. So this is the last week of our meetings. We don't have a meeting next week. And then the projects are due on the 1st. So we should be wrapping things up. But yeah, why don't we go with Layla's update first?
Yeah. So I'll probably share my work. I think once I'll try to download it and probably view this. So there are two more, like one more section left where it is more of discussion and all. So I have made a nice visualization so that we from this we can probably understand what's the work, like how it's done and all. So the data set that we have currently is basically the time point data and the lineage information data, which actually helps us to understand the entire embryogenesis of the C. elegans. So we start from a single cell and then it goes to an adult worm. This worm looks a little bit like snake, but yeah. So this was graphics that was extracted from some parts from like GBT and all. So used AI to generate this the embryogenesis, the single cell to a worm part, because it was little aesthetic.
Yeah.
And yeah, so when we are trying to understand the cell here, so each nucleus that we represent it as like a node, and this carries the information about the spatial and the lineage information. So once we push that information, like over a period of time from T0 to Tn, so from a single cellular to an adult form, so how are these are grouped? So what I have done in this work is, so we have developed a hypergraph neural network where it actually finds out which specific set of edges or which specific set of groupings it has to done it by its own. So this neural network tries to learn and adapt to the entire embryogenesis part. So this is the entire breakthrough of breakout of all the things, chunk wise what we have done. So the given the data and we feed it to the neural network, it actually temporally tries to understand from which cell it has been started and which cell it has been ended, and it tries to identify to group a certain, and it forms hyper edges. Suppose say here this is the green which is formed to the purple one, the yellow and the green one. So but later on in the time, in the developmental stage, it tries to understand and group the relevance more closely. So that's the intuition that our network does. So this is just an intuitive diagram, but yeah. So how it is done, what exactly it is done, what is the mathematical intuition, I have laid down, very neatly in the work. So last week we discussed about the contributions. We introduced a new class of growing hypergraph neural networks where we have the lineage information and also spatial information. And from that, we try to understand the dynamics of it, and we see the developmental lineage of how the C. elegans embryogenesis is happening. And after this, when we try to get the entire thing, so we try to project whatever the feature embeddings that the neural network has learned. Based on that, we provide the visualizations, and these hyper edges are provided from an embedding space perspective. So that's why we named the title as how the neural network actually perceives this given through the developmental procedure. So simply, I break down into the data part, the model part, the hypergraph part, and the hyperparameters part and the visualizations part. So first I'll go to the data and the notation part. So we observe a total number of sets over a given time period from 0 to T. So we say this is the complete developmental horizon, and the birth time takes place from 0 to T. So when we say that X, Y, Z here are the three coordinates of the exact time point of the nucleus which is present at that point, and extra T dash is basically the lineage information that we give. So it's more like an R4 space. I mean, like a 4-dimensional space. So based on this, we try to get spatial and also the lineage information, and we match it based on that. So, and I said we use an indicator function, which is I. It's basically an instance matrix, and we have an adjacency matrix and an incidence matrix, and we're gonna load it into a complete hypergraph. So just to give a understanding of what it is, I have just given it in a table that how the XYZ coordinates of some of the cells are, and how do they divide into. This is D1 is daughter, D2 is daughter 2. So what is the time points? 0, 17, and 18. So yeah. So how do we construct this hypergraph? So given a hypergraph, so we have the vertices V, and we have the lineage information small l. The edges that are related to lineage are called small l, and these are spatial SP. So whatever the hyper edge families that we have is both like we concatenate them, or basically we're gonna bring them together using these two things. That is the spatial and also the lineage. So given the alive position, suppose we take a given XT, the embedding space, and then we run a k-nearest neighbor KNN. So when we try to run a KNN, we see the closest forms, and from that we simply use a Euclidean distance to find out close similar proximity. And for this is for the spatial. So exactly we find out the unique the points that we find which come together. And for the lineage information, we try to rely on the child and the daughter relationship. And if there is more than 2 connection, then we group those hyper edges, and slowly we increase the increase the coverage of the hyper edge based on the lineage and also the spatial information that we have. So while we are increasing the coverage, so how do we expand these? So generally there are multiple expansions that we already discussed prior. So the star expansion is generally one of the good way to see it. So we use star expansion because it's it's easy to find out, and it's easy to visualize, and also we can bring back the graph from a star expansion, the hypergraph I mean. So this incidence matrix we gonna encode into a hypergraph into a corresponding matrix and an edge index. We're gonna give it to that, and we simply apply a simple neural network. So here I say the phi is basically the hypergraph convolution, and then we're gonna run an hypergraph convolution, and on top of that we're gonna mix both the spatial and also the lineage information. So while mixing, so the double dash means the concatenation. So we concatenate, and then we give it to a recurrent neural network. So when we try to mix that, so we get a better performing model. We also use transformer, but we haven't used that in our experiment. So I just theoretically mentioned that, okay, so there is a possibility that we can use transformers too. So while trying to update the temporal state, when it tries to learn from 0 to T, so we have a GRU and an LSTM cell where it tries to find out the relationship between 0 and 1 state. So what is the, here we can see, right, in the diagram. So from moving from time point 0 to time point 1, so here we have actually 3 nodes in a given hyper edge, the green hyper edge. So, but whereas we have an extra hyper edge in the next time point. So there is a possibility that there is an incremental change in the time points and they come together. So this is more of a dynamic expansion. So this is more of the KNN actually learns with respect to time. So we do not use a straightforward simple KNN, but it's more like a learnable KNN. So which is adaptable with the time. So in order to learn that state informations of the time, we use GRU or LSTM cells. So, and after that, what we do is we get the entire embeddings of the, the network. So here I have represented the entire embeddings as Z. So whatever the embeddings that we get, this is the Z. So with this Z, the embeddings, we will be able to find out that what is the optimal, we say that, the entire graph information is being, encoded into this Z, And so based on this, like the ground truth, suppose like we say the spatial information, we minimize the, the loss that it actually comes closer to the ground truth, and we get the hyper edges on top of that. So where was I? Yes, yeah. So that is the Z that we get. So how we gonna mix this Z? So we have the readout and the target. So readout is nothing but we have a simple MLP layer on after that, the hypergraphs. So or the projection layer or an MLP layer. So we call it a readout layer. So that we're gonna concatenate, that we're gonna extract using that embedding layer. So this is just a short certain amount of data or the certain type of representations which we extract from a given entire readout. So we're going to use that as, at each time step, and we're going to calculate that, okay, because we have the next time step information and previous time step. So from the birth and the next time step, how and well these embeddings are able to predict, or how well it's closing, whether it is predicting correctly or not. So we're going to use this, the embeddings. And the primary objective of this is to find out the position. So the XYZ points. So are these points accurately identified at every time step or not? So this is the loss function with respect to that. And we have a BCE logits, which is simply binary cross entropy loss, which is between the LT. LT in the sense the matrix that is generated after the prediction, and 8 is actually the ground truth incidence matrix. So basically we built a graph. So whether the ties are actually matching or not, so this loss actually minimizes those two information. Based on this, the networks actually learns to try to find out optimal hyper edges based on that. And so we aggregate this entire loss function. And once this is done, we actually map the UMAP visualizations. And so these are the the details of hyperparameters what we have used and all. So there are certain limitations to our work and that I have mentioned, and what is the possible extensions that could be done. And I need to write the visualization and the conclusion section. So probably I am planning to do that next week in very detail, because I have some good visualizations which I have shown previously, the 2D and 3D. I was not sure how to organize them and put them. So this is for the week after.
Well, that's great. Yeah, that looks very good. Thank you for going over that. So I think there's a lot of the parts are in place now. So that, are you planning to submit that document and then your repository?
I probably I will share that document with you, or we can see that we can publish that work. That I think that could be great.
Okay,
I can make it more publishable format and all, so that Anyway, we are actually I discussed with Jesse. Jesse has told me that he'll help me in organizing the manuscript and all. So if everybody contributes a little bit onto that, so if we can make a nice work, maybe not by the deadline. By the deadline, I'll be making a very nice draft, but maybe in a longer run, it could help us to make it more refined.
Yeah, sounds good. Thank you.
Yeah. And also, Vidhi told me last week that she'd be able to contribute a little bit on the sides of drawing and graphical abstracts and like the pipeline and all. So it's a little messy right now, but we can make it better.
All right.
Am I audible?
Yes.
Hello, I'm
Yes.
audible?
Yes.
Yeah, okay. Yeah, okay. Yeah, so great work. And also, so since you mentioned that you were citing transformers, like that is a possible, direction for future scope. You can also look into LSTM transformer hybrid architectures. So they are also used, and if they apply to your use case, you could also cite them as something that because what usually happens if we go directly from LSTMs to transformers, the small, like the local dependencies get lost. So that is where these LSTM transformer hybrid architectures come in. So you can cite those as well. And yeah, another piece of advice I would have is like great that you're looking at the paper and it's a good draft for now. And as you said, definitely everybody will help in. For the GSoC deadline, you can focus on having the content of this paper or a more blog readable content into some kind of a
Right.
blog or because what GSoC's official requirement is, it's on a website, it's hosted, and it contains links to everything you've done, so you can kind of link to this was my PR or this was where I posted my earlier blogs, and it links to all of those, and it's in a place where it stays for years and years. So you can definitely, if you can get a blog there, so that would be very good for the GSoC deadlines, and then you can focus on the paper in the long run. And great work.
Yep. Thank you. Thank you for the suggestions.
All right. Yeah.
Yeah.
Welcome.
All right. Thank you. Yes. So Vidhi, are you up next?
Yeah.
All right.
Even I've written a paper, but then, like, before I start talking about the paper, I'll just talk about why I chose what I chose. So there are a few things in my project, like we have different agents. So the reason why I chose different agents is because earlier, like in the previously run projects, which have been done in Oral, there have been only two types of agents, the contributor and the maintainer. But now I have distinguished the contributors as well. And the reason is because all the contributors have varied skills, goals, and behaviors. So on the basis of those, we can actually create a simulation, which is what I've done in Sustain Hub. So to enable the richer interaction dynamics and more realistic evaluation of the community sustainability. Now coming to why multi-armed bandits, it's because it improves and it helps us to model task allocation by balancing the exploration and exploitation. And we can know about the successful ones, which I have done in my project, and it provides a lightweight adaptive decision-making framework. Coming to why I chose SARSA, which is state action, reward state action, because obviously, like as the name suggests, it allows the agents to learn from the ongoing interactions and adapt to strategies based on long-term outcomes, and it captures the sequential decision-making. Also, it is an off-policy algorithm. Now, why I chose the combination of multi-armed bandits and salsa is because the multi-armed bandits ensures quick adaptive task allocation, and salsa can refine the behavior through experience-based learning. And this synergy balances the short-term adaptability. So, and also like why I chose the metrics is because they help us understand what we have done better, like the RL algorithms that we have chosen, how they are working, and how the task allocation is working. So those metrics help us understand better. Now, talking about the results, we have the harmony index, which has an average of about 0.8 to 0.85 after the first two runs, and then it reaches 0.9 at its peak, which is a very good value because we set the base values around 0.6. So, which is good. Then we have the resilience quotient, which does not go above 8, and when it goes low, it does not go negative, so it is good. However, it is completely based on the number of dropouts per step. So yeah, like I've already mentioned it previously, that it's stronger with fewer dropouts, and like with higher dropouts, it reduces. The reassignment overhead is 1 consistently, which tells us that every task, which is whenever the agent drops out, the task is reallocated always, so it is a positive sign. Then the 3 distinct types of agents obviously help us balance the workload, but then we have these metrics which helps us more. And yeah, like about how I've chosen MAB and SARSA, which I said previously, that it helps us balance the short-term adaptability. And of course, it's quite scalable. And the most important part, that we have a graphical user interface which has quite a few parameters, so the user can adjust the parameters according to their needs and conditions. So this is the paper which I wrote. I was just trying to get everything together. So I haven't mentioned any authors yet, but I started with the introduction about what is Sustain Hub. First is the abstract, which I had mentioned even in my proposal, that like what is the project and what is the importance. Then I've introduced my project, that Sustain Hub has like 4 agent roles, and how I'm using the 2 reinforcement learning algorithms to actually implement this project. Then I've gone into details and I've explained how reinforcement learning is actually involved in this project. But before that, I have just explained a bit about multi-armed bandits and added the diagrams so that we can get a visual understanding of what multi-armed bandits are. So then I've explained about how the exploration and exploitation trade-offs work. I've mentioned a bit about the reward system, but I explained it more in detail in the Sarrah section. Then how the theoretical value helps us, and it's more than just math, and how the multi-armed bandit, the whole problem is actually applicable to sustain up, and how the maintainers can allocate the tasks using it. Then talking about Sarrah, I have shown the equation, and like along with the equation, I've explained what each term in the equation means. Where this is the current state, like this is the current state, and this is the updated state, and what alpha means, what gamma means, and what each of these terms mean, and how they are involved in what outputs we get. So I've explained how we have different types of actions that the agent can either accept and attempt the task or skip the task and attempt the task outside specialization, like in case of, like especially in the case of reassignment or the resonance quotient where agents skip out. Then I've explained the reward system, that it's +3 for the tasks in which it specializes. For example, the innovator will be completing a feature, so it gets +3, but +1 for the other ones. Similarly for contributor and knowledge curators. Then I've explained why we need Sarrah, because of course it balances the exploration and exploitation, and most importantly, it's an on-policy learning algorithm, and it does not focus on the best optimization, but it focuses on what it has done so far, so it's better to predict. Then there's an example which explains how the steps take place. I'll probably add one more picture of the logs over here, so like this example can be explained more better with what has happened in Sustain Hub. Then something about the impact on the simulation, about how the system level, like the maintainers learn allocation policies and everything. Then yeah, like it's a repetition again of what I said in the PPT, the synergy of multi-armed bandits and Sarrah working together, and how it's quite lightweighted and not everything depends on just one algorithm. Then this is just like a detailed description of the project, like there are 4 different types of agents and what each agent does and how it is supposed to specialize. And I've added references wherever I could add, like sorry, I forgot to mention, I guess. Okay. Like for the maintainer, I think, like okay, yeah, like we can see over here there are a few references that I've added, like for the first paper, second paper. Then the agent summary of how everything works. Then I've added a section about why we need the above agents, and it's the same thing that I mentioned previously, that we need them for smooth functioning and to actually see what is happening, and so that we can use these different parameters in the agents itself to understand which agent can do what better. Like we can obviously add parameters to the metrics that we have and the graphical user interface by adjusting the number of agents I want. But then if we can add a parameter to the different types of agents itself, it can help us, like it can help us from the very first step itself. Then talking about the 3 different types of metrics that I've added, which is the harmony index, resonance quotient, and the reassignment overhead. I've explained what each of the metrics are, what their importance is, and what is like how I've illustrated them and how the outputs are. So we can see over here that this is the harmony index. So the first few steps, that it starts from 0.5 or 0.48 or something, and then it increases. But then eventually, after a lot of simulation runs, we obtain a good balance, which is above 0.8. Then the resonance quotient and how the resonance quotient works, like what the formula is and what its importance is and how I got the reference from which paper. And I've explained how resonance quotient works under different circumstances, like this is with a higher agent dropout and it goes slightly below 1, but then this is with a lower agent dropout per step, so it does not go below 1. Actually, it's quite good. It's somewhere between 0.4. It's somewhere between 4 and 5. Then we have the reassignment overhead, which explains that every task which had to be reassigned is reassigned. So we get 1, which is a good value. And then again, a table for metric summary to explain how each of these metrics work. Not explain, but just summarize how everything works. Then I've added about the graphical user interface, like there are logs and how each, like how the graphical user interface has a few parameters that we can use to know what will happen under different conditions. So the stepwise logs will be coming in the terminal. Then the different graphs and how they will be displayed. And I already explained the graphs previously, so I did not explain them over here again. It's just about how the visualization is in my case. And then the final visualization where we can see the blue circles, which are the agents, and the yellow squares are the tasks, and the agents keep moving, and how I've used Tinctor and Net logo for my entire visualization and graphical user interface. And in the end, I've added references. Like I spoke to Sarah, and she said I can add more results and everything, so I will work on it. And I will send this paper to you as well, Bradley, so that we can work on it. Like everyone can contribute and we can make it better.
Okay.
Then I just updated the README about what Sustainable is, the project motivation and the objectives, and like how we can run the repository, like how we are supposed to, how another person can clone the repository and run the software. And I just updated I wrote the final blog. This is not the final blog, this is just the week 12 blog. I'll add a final GSoC blog, which I'll probably be submitting. So these are the pull requests. Like I made some pull requests today, and 3 of them have been closed, and 3 are yet open because I just opened them before the meet. So I've opened these pull requests, and hopefully they get merged. And once they are merged, I'll start working on the final blog where I can put everything.
All right, that looks good. I like that you have a paper available here. So, yeah, that's great. And so I accepted some of your pull requests earlier, and I'll accept the next one, the next batch, when I get out of the meeting, and so that should be okay. I see you've also made some issues in the issues section of the repository. So, yeah, and a word for Lalith and Jayadratha, of course. Please make some issues for sort of follow up to the to what you're doing, because we want to be able to maybe have a starting point for next year, or if people want to continue with the project, know where things need to maybe happen, or what things are still outstanding. And I don't know if Lalith or Jayadratha have made any pull requests. I'll have to check that after the
Yeah,
meeting.
I have. I did that today.
Okay.
So please check once. And it is not the entire work, but like probably 2/3 of the work I have already done.
All right.
Yeah. So and the rest of the thing I'll like upload within few days, 2-3 days, and
Okay.
I mean those things are already done, and I just have to I have created a folder, nicely like presentable GitHub repo, and there I just have to add all those things. Whatever experiment I have done, that I'll add there. Repository I built, and this is what I have like submitted for the PR. And if you see, this is the like 3 notebook I have, where you can find everything, the data set and their statistics and all kind of visualizations, whatever was there. And all these are there. Whatever I have done, I just put it nicely here after all the experiment, the final thing. And also, like last week, I was not able to fix this. there was some bug here, and now I was able to fix it, and the DTDG part is also complete here. So if you see, so like this is for time point at birth, and how each node is going to connect with other node, and how each of their connections are. So if it is a directed connection or one-way connection, so that will be directed. It is shown directed, and here there is some node which is not like not one directional. It is bidirectional. So here I have shown what are the how many synapses are there, and if it is bidirectional, and what kind of edges are there at that time. So one synapses is like this SAADL to RIML, and it has strength of 2, and the other has RIML to SADL. It has strength of 1. So that is what I was able to, I did. And so if I play here, so it will go till the time point 8, and it will show the entire process of how how the connectome network that is growing based on the paper that nature paper and their data set. Yeah, I guess it is going. There is some problem of it's not a problem of the visualization, but it's problem of how it is rendering, because it is taking lot of memory while it is rendering. So that's why maybe it is showing like this, but actually it is a lot better. So maybe I can show you. Sorry. Yeah, this is the one. This is the final one, I guess, at time point 8, and like you can see, if you hover over each node, you can see what number of connections are there, and what is the ID of that node, the name of the node, and how many connections are there. Here, for suppose it has only one connection, that is the chemical connection, and it has strength of 2, so that is total synapses 2. And since it has only like one neighborhood, that's why the like this node is also very small. But here, if you see, it has more strength. That is, the unique neighbors are 13. So it is like 13x of this, the size. And then how many connections are there, and which of them it is connected to, that is also like it is showing. So this is the entire connectome network of C. elegans since birth to the adult phase. And this is what I have done for this week. And also, like, I have created this this like repo, and that is what I have uploaded also.
Okay.
Yeah.
Yeah, so it has
So
everything in it. Yeah.
Yeah,
Okay.
it has everything in it. Only this part is left, this one, and this I have cleaned. That's why I have named after it. And I'll just like all the code that is here, I'll upload, and that will be my final like repo.
Okay.
And also I'll write a blog, whatever I have done.
Okay. Yeah, that's good. I was going to ask you about visualization, or
Yeah,
documentation. Also, the visualization, though, you might want to take some screenshots if you can, and put them in the repo.
Blog.
Or yeah, you could do that too, I guess.
Okay, yeah. So those visualizations I am already saving here in the like if you see in dataset output, these are the visualizations that you can see. So like all of them are here.
Okay.
Yeah. So like I just Git ignored these visualizations. So if someone runs, they can see in the actual repo. If you like, otherwise it will be like very big. I mean, lot of files are there, and that is more than maybe basically MP4 file or HTML file. Those are like this one. This is itself 71 MB. That's why loading it and running it is taking time, and also some artifacts, unexpected artifacts are also coming. So I can upload those in here only. And this is a PR request I have uh, like done today.
Okay.
Yeah.
All right. Yeah, it's good. I'll take a look and accept it.
Okay. Yeah, that will be great. Thanks.
Yeah.
Yeah. Okay.
All right. Thank you. Yeah.
Yeah, and like these I mean, after running only I have put that these IPONB file in the repo, so anyone can see also these outputs. So these visualizations will be there.
All right. Cell division visualizer. Okay.
Yeah.
All
Okay.
right. That's good. Thank you.
Thanks.
All right. So we had a lot of things in the chat here. I guess there was some discussion about people exchanging emails and other things. Yeah. Okay. So let's keep on that. I'm glad to see that Vidhi has also gotten a paper together, and it's not required, but it's nice to have a good start on that. So a couple words about post GSoC. So this is the last meeting for the year for this group. I want to keep in touch over the next week, make sure that everything is, um, comes to completion by the deadline. You remember it's a hard deadline, so you can't get an extension on it. You have to submit it by the specified time on September 1. And then, we want to just pick a stopping point. I think all of you have picked a good stopping point. But we also want to think about maybe what to do next after the submission. And so I think, having that paper draft or the manuscript in place is a good start for that. I think, yeah, definitely everyone should at least think about writing up something as a paper, but also just kind of like what kinds of ways can we utilize the software, because there's a lot of good software here, and we need to, what tends to happen after GSoC is over is that software just gets kind of lost to time, that people don't work on it anymore, they don't use it, and so it just sits there. And it's nice to have, maybe for someone else to pick up later, but it's also nice to be able to use it in some way. So I'm open to any suggestions as to if we want to put out a formal release of a piece of software, or if we want to build on top of it for any reason that you might think of. So please think, maybe about longer term use of the software. How should we go about doing that? All right. So that's good. Thank you. Thank you to everyone for your presentations and being on top of your projects. Okay. So yeah, no more questions. And again, make sure you make your pull requests, and I'll review them as soon as I can, and we'll get that through the system. Okay. So it looks like Jesse's here. I don't know if you wanted to give an update or what you wanted to talk about.
Yeah. I mean, I don't want to add to. I don't want to cloud the meeting with too much other stuff. But I want to say, yeah, it's been this summer. I know I've had a lot going on myself, but it just feels like the summer went by very fast on these projects, and there's so much that's happened. Like this has been a really good summer in terms of working on things, getting them out, doing code, doing presentations, making the papers. Like, this is actually really nice, and that this isn't not everybody at the end has tried to make some kind of a paper that can turn into a publication or some kind of a preprint or something like that. And I think that's really nice. And I think that's what should happen. So I'll just do a general +1 to everything Bradley said in terms of staying in touch on this. I'm crafting an email right now that has everybody's stuff in it, just so we're all here. I'm even trying to get some of the other folks that join us before, just so there's sort of a collective email thread. I know we're in Slack, but Slack's, it's tough sometimes there. So email's a nice thing to have. And I want to affirm that, as much as you guys want to continue to work on this or develop stuff or make, a preprint type thing, or even do even honestly, obviously there's the Medium post, but our Medium's, one venue, but if you want to refine this into, maybe a preprint, but also some kind of a slightly more polished academic facing article, or public facing article that's more academic or rigorous, or goes into some technical detail, but also has, stuff like that. I'm certainly willing to help with that. I've done that before. I'm doing that with some other interns. I know Bradley has experience with this. And so we do really want to say, yes, the number one priority is complete the Google Summer of Code requirements at the deadline. That's obviously all you really need to think about between now and the deadline is that. But I think I'm just reiterating, extending a big extension of our hands and support afterwards. And you'll be, I don't want to speak for Bradley, but you're welcome to do as much and join and stay on in terms of the Saturday meetings and whatever else. I think this particular Friday meeting specifically, the time zone will be no longer in use. Or are we doing anything else in this Friday time zone ahead, Bradley? I don't remember what this plan is for that.
I am doing something kind of separate from that at this time period. So,
Okay.
Yeah, we're not going to have this time period available anymore for the rest of the year. So,
okay. So yeah. So then understand that, and this is sort of a later time anyway. No more Friday meetings proper, but that doesn't mean you can't talk to us. Or present at Saturday meetings or the Monday meetings or whenever, or also just schedule, hey, can I talk to you guys about blank at a time? There's a lot of opportunity for that. We want to make sure that's, go as much with you on that as you want to. Okay, so that was my generic commentary on that. Oops, sorry, I'm trying to copy this other thing here. If you all want, this is a really small thing and it's a last minute thing, and I don't want to I don't want to make any pressure about stuff, but I am going to be presenting in a broader. I have a broad presentation tomorrow, and actually things are kind of starting today at the summit. I think I've talked about this before, but it's the I'll just share my screen because I can do that. Forget I'm actually at a normal computer for a moment. The Augmentation Lab Summit. Is this super relevant to Google Summer of Code? Not really, but I'm there for other reasons, and I have a big poster, and I kind of plug, hey, we also supported this Google Summer of Code project, and they're very interested in a lot of these relatively beneficial things and technology futures at MIT. So if you want and you're comfortable with it, I can try to mention, if you have a blog link or a post or a site or something you want me to mention for your project, I can at least mention it and see if anybody's interested. I'll basically have a poster and talk to a lot of people during the day. So if you want me to present indirectly in a low level scale, anything that you want me to try to network or mention to people here, you can email, honestly, just send me an email or send me a Slack message saying, hey, here's what you can try to show off. It's not really Google Summer of Code related at all, but for the sake of trying to help you network, and as something that I can offer in professional development, connecting people since let me know. It's there. I'm going to be there pretty much all day and talking to a lot of people about it. I mean, it's starting now. Folks are like already in Boston for it. So they'll be here tomorrow, throughout tomorrow and the weekend. Let's see. Some interesting related things. Can I make this happen? Let me see. Twitter's kind of weird about this sometimes. Yeah, I haven't posted, right? I'm going to stop sharing this screen and show something else as a slight interesting tangent to this for someone who will be at the same event. Yeah. So there's someone there. If any of you guys, I don't know, remember how much we talked about it before. That's not it. Where is it? Yeah, you're seeing this, I think. There is someone. Yeah, here's what I want to show. Daniel Van Zant, someone with Echolopto and all this stuff, and is looking at this new way of doing research, and is also doing something that's similar to I don't know if it's going to show up on his website very easily or not. He's doing a lot of like frontier map adjacent things, and you can't see this. Sure, this tab instead. Yeah, he's doing a lot of frontier map related things, and also things that kind of were like state of the art AI. So I'm going to talk to him a lot this weekend about that. But more about that Saturday. There's a lot of interesting things happening in and around the event, but I'm kind of using it to sort of promote some Joe Pro things and some things in the lab that might be relevant, and stuff like that. I won't. I keep messing this up here. I won't linger any more on this. I really think I think it's been a very nice season, summer of code, and I'm curious where you want to do next. I'm having a lot of conversations with like the data and direction group, which I'm going to try to also do a little bit of previewing some of their work at the event too. But a lot of what I'm trying to do with data and direction is offer them different opportunities to continue for those that want to as well. So I mean, a cool thing that might be we can try to do for next time. Again, the priority for you guys is your school summer code things, but and the deadline. But outside of that, I may try to do some kind of a summertime recap, like either some kind of a post or just a discussion session or a review about it at like one of the Saturday meetings, just to kind of capture what's been going on in the lab and the adjacent stuff that hasn't been featured here, like some of the data direction stuff, some of the other things that have been going on, because there's been a lot of things that have happened this summer, even though it's been sort of segmented out or not, not as apparent, but it's been a busy summer. So I think everybody's done well, and I just I'll do an actual self emoji clap, but like a round of applause for everybody in the front. It's been very good. So that's my real comment for today.
Oh, great. Thank you. Yeah. I don't know if you want tomorrow. You mentioned that you might want to do some sort of live.
Yes. And I'm trying to now their schedule's kind of weird. Okay, let me look at the schedule. I'll show this again for tomorrow. Is this working? I think this is it. Yeah. So here's the actual schedule for tomorrow. This is an East Coast time, so we'll technically be around here. So maybe around 11, I could stop in.
Okay.
Because that's when they're doing some other showcases. I'll be there the whole day, but I picked this time for some other stuff because like it's less. I'm going to be doing a lot of things during here, but I might try to check in around 11.
All
And
right.
I'll put this in the chat in case anybody would ever heard. Yeah. But this is the actual schedule for the event. It's cool because of these folks here, but then also like I'm really looking forward to Pat. He's done a lot of cool stuff. Dr. Natalia is someone also with MIT Media Lab fluid interfaces type thing. So there's a lot of cool stuff there. But yeah, it'll be fun, and I'll target for 11 and let you know. I don't know what's gonna happen, but
Okay.
at the risk, try to record some kind of a video too if I can't do it live.
Okay. That sounds good. Thank you. Yeah, it looks like an exciting conference. And I know you're meeting Morgan there, so he's probably on his way in.
I imagine he's probably like in the air right now or some other traveling here because everybody's supposedly getting in like now and tonight. So should be fun. I'll try to take some pictures and do other nerdy type stuff.
Yeah. All right. Thanks. Looks like in the chat, Vidhi she thanked everyone in the group. Yes, thank you to everyone for their help and feedback. Okay, yeah, and so yeah, we'll continue on with Saturday morning NeuroSim and DevoWorm. So you're welcome to join in those as you wish. Okay, I have a couple things to share for sort of the last feature of this meeting series for this year. There are two articles here that one is not in the Slack, but one wasn't from the Slack. So this is an article on advice for whiteboard coding interviews written by this person here, Satnam, and he has some advice for whiteboard coding interviews. So a lot of you, if you're going up for a job, for a tech job, they'll give you a whiteboard interview where they'll ask you to solve a problem, and you'll have to do it sort of, right there in front of everyone. You have nothing to consult. You just have to kind of fly by the seat of your pants and draw out a solution. And then, they might help you, they might not, but then the whole idea of one of these kind of exercises is to see how you can think on your feet, how well you think through a problem, etc. There's an analog to this in academia, which is the chalk talk. So in biomedical departments, oftentimes they will have like someone will get up and give a chalk talk on an idea, and they'll draw it out on the board, and then people will ask them questions about, oh, did you think about this, or have you thought about that? And so that's another way that you can get, there's a very exciting atmosphere there, but just by going through and drawing something out step by step, or drawing out a process and then thinking about how it fits together. So this is, of course, though, for a job interview. So this person has done a lot of these, and they just have some advice here. This is specifically for software engineering positions at big tech companies, but that's not the only place that these happen. So, just to be transparent about that, he mentions that whiteboard coding is stressful, where you are alone in a room with someone who is scrutinizing everything you say and do as they write notes about your performance. There are a lot of power imbalances, so you, as the interviewee, don't, you may feel intimidated, or you may feel, it depends on the person running the interview. Person running the interview may be aware that they are sort of in control of your fate, and they may actually do a good job, or they may do a very poor job of eliciting your response. So, it's not an exercise where you just brain dump everything. You work with the person in the room to get the best answer. And so the point here is that they, there are a lot of biases as well that go on in this sort of interview setup. So, all things to think about. If you're doing an interview, but also if you're giving an interview, which I think is more important to really kind of consider how it's set up. So, to do this sort of thing, you want to be prepared. You want to eat beforehand and drink, and you don't want to go in, with a hangover. You don't want to go in with any sort of like problems, like you don't want to have to go to the bathroom in the middle of it, or you don't want to be sleepy in the middle of it. So, and then you want to be able to practice the coding interview questions. So a lot of times people will fail the first time because they don't prepare significantly, and they don't know what to expect. So this person failed the interview process at Google the first time they applied because they did not prepare and were not expecting to write generic code on the whiteboard at the drop of a hat. So that's oftentimes one of the requirements is you'll have to write out code and kind of write it out with maybe with a Sharpie or something. And that's different than like typing it out and kind of thinking it through, and because of course the medium's different, but of course you also have to know the syntax and write it out and like reason it out as you're going along. And so it's very much, you have to have some mastery of it, I think, at some level. So it's going to be different for depending on how you approach coding, it's going to be a different experience. So if you're, writing code every day, professionally, you have a different style than if you're a researcher producing prototypes. So there's a lot of style that goes into this, and that's something that the interviewers expect. Depends on the job. Sometimes the style isn't as important. Sometimes it's very important. And then, of course, you need to know what programming languages they want you to use or what they accept. You want to, and Python is a pretty good, all around accepted language. But of course, if you're applying for a job where they want you to write in a specialized language, then of course you want to know that language. And so just set the parameters of this sort of exercise in advance. Then you want to demonstrate your problem solving skills. So a good interviewer is not going to ask you to code up anything very big or complicated. And so don't worry about like being really fancy. Just try to be very basic in terms of what's asked, and just don't try to implement anything too flashy, because you have a good chance of failing or not being complete enough for the interviewer's satisfaction. You also want to talk through test cases with the interviewer early in their interview, which will help you understand the problem. So you want to be able to, before you get into the code, you want to look at the forest, and then draw out the trees. That's a metaphor, meaning that you want to understand what the problem is, how it might be done, how it might be framed, and then approach the problem in code. And then write your code. Address ambiguity, of course, and this is again where you want to disambiguate everything that the interviewer asks, or any ambiguity that exists in the problem in your mind, because when you try to write it out in code and be very specific, you won't get it right. You also want to have some basic knowledge of different types of things, like space and time trade-offs for different data structures, and have a basic level understanding of big O notation and how computational complexity works. You don't want to write a solution to a problem that is, runs in a certain time, and, you're specifically asked to do something that is not in that specific time complexity. So, you want to be able to match the expectations of the interviewer and do that effectively. Yeah, you want to be able to simulate your test cases, walking through it line by line, acting as human debugger. Keep talking while you do this. Don't have a lot of dead space. And then, of course, don't panic if you hit a wall in your mind or if you hit a wall on the board. Just, don't say to the interviewer, is this right? Can you think of a better way to do this? Or did I pass the interview? It's not good to do things like that. You just want to kind of work your way through it, but do it in a way that's confident. Be formal, polite, and respectful. Do your homework, of course. Ask questions, and then good luck. So that's a good, I think, overview of that sort of whiteboarding activity.
I have a question for you, Bradley, and I imagine I don't know how many interviews you've conducted. I don't think I've conducted a proper full whiteboard coding interview with anybody, so I don't have that experience. I've done some things in being the interviewee, but I haven't conducted one, and I wonder when you're making an interview of that nature, I wonder how much, or if there's variation in I know sometimes interviews specifically about, can someone do they know, interview as a test, as in, do you know how to do this? Can you solve this problem given this code and this setup and these constraints, or there's sort of a right answer they're looking for, but also some of the times it's just a matter of, in a pressured situation, trying to comprehend your decision making at all. And so I guess my question is sort of do you have a sense of what, and I know it's different for different environments, but do you have a sense of is it more about getting the right answer, or is it more about them being able to see how your mind is working and grasping the problem? I'm not saying the right answer isn't important, but more you get what I'm saying. I'm curious how you break it down in that sense.
I think most people expect this to be like a problem-solving exercise. So I don't necessarily care about I'd like the answer to be reasonable, like I mentioned with computational complexity. I don't want you to, propose something that's wildly inappropriate and then work through the problem really well, but it's not going to solve the problem, because anyone could do that, I guess. The whole idea is to walk through the problem. Why did you do this? How will you do this? There are going to be maybe some technical problems, debugging that happen. So how do you deal with that? It's kind of like what we do in the Google Summer of Code, right? You propose a solution to a problem that's posed, you work through it, you schedule it out, and then as you work through it throughout the course of the semester or the program, then you kind of have to do the debugging and this problem solving in real time. Do I need to spend a lot of time on a problem, that I can't solve, or try to find a workaround, or how do I do that? Time allocation. And that's how I would approach it. Now, other people might say, well, I would really like the right answer, which I think is more of a, we have, 400 candidates and we want to get down to 2 or something like that. But that again, like I said, it's up to the interviewer as well as the interviewee to approach this in the way it was intended, I think. So, and you put a comment in the chat here. Yes, a general good thing to do in interviews is confirm or prospect, feel out what is it the interviewee seeks.
I should say interviewer.
The interviewer sees the problem. It's a balance between that and not looking like you don't know enough. And are you asking them to explain everything to you? Yeah, and I've been to Chalk Talks too, where the whole idea is okay, here's this problem, let's solve it. But there has to be this dialogue between the people in the audience and then the person doing the Chalk Talk, and then they have to kind of, maybe ask. It's kind of almost like, a demo or die situation, where you give a demo, you say, oh, how does this work? And then you go into that. Oh, how does that work? And then you both kind of work out some of the details maybe that are missing. There's no right or wrong answer, but you do have to, kind of work out something. There has to be some point to it.
Yeah, I was actually thinking of demo or die. And just to follow up on my comment, I think one of the worst interviews I ever gave, well, I don't even know that. That's the thing. I don't know if it was. I'll take that back. That may be the wrong framing. At the very least, I was able to ask what they didn't like about the interview, and they said at the time that they interpreted I basically did what I said like I went to the far end of the pool. I was very inquisitive of them about, oh, how do you see, almost like I was interviewing them,
Yeah.
which isn't necessarily the wrong thing to do. It really depends. Like it's one of the big unknowns, or the things you don't know. If you could get any information or tip off about how the interviewer does this, that's great. But it's sort of this balance between trying to understand what they see the problem as and what you want to do, versus if you ask them too much, they'll be like, geez, you don't know anything. Why are you asking me for the context? You should know this, or you should have assumed this, or you should have done this kind of research or whatever. And I'm mentioning this not to be like scary about it, but more, it's such, you really do want to know your audience and know who you're talking to. But there's also a very delicate line of knowing when you should just start making something, or like start explaining your solution, versus trying to do too much. And I think Bradley, that's maybe more of a conventional interview. So what Bradley was talking about was a whiteboard interview or a chalk talk, which is inherently a bit more dialogue oriented. So again, it's kind of knowing who you're talking to, what it is, and so on. And I always recommend one thing, whatever interview you're at, especially if it's a phone or you don't know the person, you can't see the person, whenever, always confirm that you're interviewing with that person for what you think you are doing. Because sometimes, especially in smaller groups or startups or whatever, it's just, people will put the wrong people in the wrong categories. And it's just a good practice of, hey, I'm doing this. I'm at this stage. I'm applying to this job. You can say that to them or ask them to confirm that with you. Just because that, especially in the fast-moving tech world, I think that happens more than people realize, that they kind of mess up there, and then you can waste a lot of time. So that's my only other parting advice for this and everything else. But good luck with everybody. I'm sure you have a lot of future interviews ahead. So
Yeah,
sure
yeah, definitely. The last thing I wanted to mention was this. Last thing I wanted to mention was this article. This is in the Slack. Something Jesse, I think, posted from LinkedIn. This is on GitHub's fall. So, we've been using GitHub, and a lot of people, I think, rely on GitHub for a lot of things. And GitHub used to be kind of its own company, and then Microsoft bought it. And then Microsoft has really been kind of moving in the direction of incorporating AI into GitHub in ways that maybe people who are using it to develop are not necessarily on board with. So this is GitHub's fall, Microsoft's AI takeover, developer betrayal, and the next fight for digital sovereignty. And this is Dion Wiggins on LinkedIn. And so it talks about Microsoft kind of doing these things with AI, but what the downside of that is, there's an upside, of course, that it could be helpful to people in certain development contexts, but it can also be bad in terms of platform trust. So when when a company will take over a platform, sometimes they do things, they make changes that destroy the trust in the platform. So, like, one example of that is this phenomena of enshittification, where you have a product and you sell it, and you provide a service that people want, and then the service begins to degrade, and that could be because they want to change things based on maybe the new company's mission, or they might want to get shareholder value back from the platform, and so the service suffers, and everything goes to shit, apparently. And some of this is, the AI policy also involves a lot of privacy issues. Sometimes you're working on things that you don't want, to maybe open it up to like training sets, if your project is sensitive in terms of security or something like that. So there are a lot of things that can kind of conflicts that can occur from this. And so the Too Long Didn't Read version of this is here. Microsoft's full-scale takeover of GitHub is the final blow to developer trust, turning the world's open source backbone into a proprietary AI fuel and erasing any illusion of platform neutrality. Once again, promises were made, trust is broken. Just another step in content theft from big tech and big AI think they can get away with it. Developers, governments, and organizations worldwide are now at the mercy of corporate and geopolitical power plays. The only way forward is community-led rebellion on new, truly sovereign commons before software freedom is lost for good. So it's definitely like a position piece here. And so this is basically looking at some of the restructuring that's being done through Microsoft's ownership of GitHub as a hostile act instead of routine restructuring. And, just kind of thinking about this in framing this in the history of computing, being able to access a program and learn from your programming so you can take the code, you work with code and you learn from it. So this is kind of thinking back to 1981. We passed around code through magazines printed in hex or Sinclair Basic pages you painstakingly type in line by line. So you take like some printout and you type it in. The real learning didn't come from retyping the code from the magazine. It came from the hours spent debugging, chasing down errors, and deciphering the logic behind every command until you understood what was really happening under the hood. So this is like basically this sort of practice sort of has evolved into the modern sort of forms of programming where you spend time with the code, you understand the code, you debug the code and everything. And what he's hinting at is that AI assisted coding can destroy a lot of that practice. And so his point here is that going back to the origins of sort of modern programming practice is that shared struggle built a culture of trust, resilience, and real collaboration. We were communities long before platforms, and every bit of progress came from open sharing, not corporate gatekeeping. So this is again, thinking maybe about the culture and practice of programming and how when you have things like AI assistance or when you have certain innovations at the platform level, they can kind of come into conflict with those cultural expectations. So that's, you can read that article on the Slack if you're interested. Thank you, Jesse, for posting that.
Yeah, and I think I will very briefly mention something. We didn't go here, and everybody wants to go, but I'm gonna mention I'm gonna mention a. Oh, it's not showing. I'm going to mention Karen Howe in the book Empire of AI, just because I think that's something that people should read going forward. I also just noticed for the first time, there's the two different type book covers.
Yeah.
One's like way more on the nose. One's like Sam Altman AI Nightmares, and it's Inside the Reckless Race for Total Domination. And there's many things about it right now, but I would just say, as our little nod to ethics and whatever else right now, there's many different things that play in terms of big tech and governance, and the story that Bradley showed about Microsoft acquiring, GitHub is just that's sort of what we're in. We're in this era of acquisition of data and opportunity and substrates and that's the whole conversation for another time. That's some things that I'm talking about with data and direction and Joe Pro and other ethics stuff, but just sort of things to be aware of going forward. And anytime you want to talk about that stuff, you're welcome to reach out to me or here in the lab. But yeah, like just there's a lot going on, and you all have interesting things to do. But we support you in them, and I'm very curious to see where you go with it. But I think anything else you want to say about the article, or are you going for a wrap up here, Bradley?
I think that's it for today. All right.
Okay. Well, it's been a great summer. And again, stay in touch. I'm drafting an email now that I'll send out in a little bit with a few other links and stuff just to kind of get everybody together and, just to have it there. But I'll be in touch that way, and good luck with everything ahead for you all. It's been a very good summer.
Thank you. Bye.
Take care, everybody.
Take
Bye-bye.
care. Bye.
Bye. Thank you. See you.
Bye. See you. Thank you.
Thank you, everyone. It was great summer, with all of you, and it was really great.
Oh, good. Good.
Thanks.
Thank you. Yeah. All right. Thank you.
Bye-bye.
Bye.